Okay, so we've got some Algebra 2 stuff here. Looks like it talks about conic sections.
Right.
And it mentions 4 types. Parabolas, circles, ellipses, and hyperbolas.
Right.
So like in this deep dive, maybe we can try to just like quickly, clearly figure out what these shapes even are, you know?
It sounds good. Yeah.
So-
Just like a rapid fire guide to these fundamental curves.
Okay, cool. So maybe we can start with parabolas. What comes to mind when you hear parabola?
Well, I mean, it's that classic U shape, right?
Yeah, like if you toss a basketball or something.
Exactly. But to get a bit more precise, like the actual definition, it's the set of all points that are the same distance from a single point, called the focus, and a straight line, which is called the directrix.
Focus and directrix.
Yeah. What's cool is how that simple definition, leads to that specific curve.
Right.
And it also explains why things like satellite dishes are shaped that way. Like they can focus incoming signals to that single point, the focus.
Oh, that makes sense. Okay,
Yeah.
so focus and directrix, equal distance. Got it. And then so next up we have circles.
Mm-hmm.
I feel like everyone knows what a circle is, but like where does it fit in with all these other like conic section things?
So a circle is basically the set of all points that are the same distance, equidistant from a central point.
Okay, yeah.
But here's something interesting. You can actually think of a circle as a special kind of ellipse.
Really?
Yeah.
How does that work?
So an ellipse is defined as the set of all points where the sum of the distances to 2 fixed points called the foci is constant.
Okay, 2 foci.
Yeah, so now imagine those 2 foci moving closer and closer together.
Okay, so they would like eventually merge.
Exactly, they become a single point, which is the center of a circle.
Oh, so a circle is just an ellipse, but the 2 foci are in the same place.
You got it.
That's cool.
Yeah. It is, right. And that also kind of leads into the general shape of an ellipse, like it's like a stretched out circle or a squashed circle. The further apart those 2 foci are, the more elongated the ellipse becomes.
All right, so instead of one central point, you have 2 focal points kind of like influencing the shape.
Got it. Okay. And now for the last one. Hyperbolas. They sound like the most different from the others.
Yeah, they do kind of stand out.
Yeah.
Visually, they're quite distinct. So a
Yeah.
hyperbola, it's the set of all points where the absolute difference of the distances to 2 fixed points, again, we have these foci, is constant.
Okay.
But unlike an ellipse, which is like one closed curve, a hyperbola has 2 separate branches. They're symmetrical, and they kind of open away from each other,
Oh.
almost like 2 parabolas facing opposite directions.
Okay, so I'm noticing a pattern here. With an ellipse, the sum of the distances is constant. But with a hyperbola, it's the difference that's constant.
Exactly. It's a subtle but crucial distinction. Yeah. And it's kind of amazing to me that all these shapes, they look so different, come from these like very precise geometric definitions.
Right. And if we zoom out a bit, all of these shapes, they can actually be formed by taking a plane and intersecting it with a double cone at different angles.
Oh.
That's actually where the name conic sections comes from.
Okay.
It all depends on the angle of that slice. You get a circle, an ellipse, a parabola, or a hyperbola.
Wow. So there's like a single underlying like geometric idea connecting all of them. That's really cool.
It is.
So just to recap for everyone, parabolas, they're about equal distances to a point and a line. Circles are about equal distance from a center, but that's like a special kind of ellipse. Ellipses are about that constant sum of distances to 2 foci, and hyperbolas, it's the constant difference.
Yeah, that's a great summary. And you know what? Keep an eye out in the world around you. You'll start seeing these shapes everywhere.
Oh, yeah.
Yeah, like architectural designs or even the curves you see in nature. They're a fundamental part of the geometry that surrounds us.
That is fascinating. So maybe now, like, armed with these definitions, our listeners can go out and start, spotting these connect sections in their everyday lives.
Definitely.
Thanks for diving in with us.
My pleasure.